Hi guys, happy Monday. Hope you had a good weekend. This is Mrs. Fates. This is going to be the first step of today's assignments. You will be watching this video note sheet. No, there's no actual note sheet to download. You just need to be watching this video. Miss Henderson and I can't stress how important these videos are. It's us teaching you the new material. So it's really, really important that you watch this. Today, we are going to start writing two-step equations. If you remember from last week, we introduced you to writing one-step equations, and they're going to look really similar to writing a one-step equation. We're still going to define our variables. We know that an equation needs to have an equal sign. The only difference is when we read a word problem now, there's going to be like an extra piece or an extra number that we have to kind of put into that equation. So we have to read the word problem very carefully to make sense of it. And then I think once you do a couple, you're gonna get the practice that you need, and it's gonna hopefully start making some sense. After you watch this video, you will then complete the Microsoft Forms practice problems, and that automatically submits to Miss Henderson and I. So that is what your activities include today. So like I said prior, we are writing two-step equations today, and what we're going to do is we're going to start with problem number 1. So I'm going to read it out loud, and I'm going to highlight key information I need in order to write the equation. So it says Hunter and his friends drove together to a Friday night football game. The cost per ticket. I know per means one. So the cost of each ticket, so each person attending, to enter the game is $4.50. I'm going to highlight that. Plus, okay, that gives me a huge keyword. Plus I know means to add. So plus an additional parking fee of $7. Write an equation that represents the total cost to go to the game C. All right, there's one variable. Based on the number of people who buy a ticket T. There's my other variable. So just very similar to last week, Miss Henderson went over this in her video. Label the variables, okay? So we need to write our let statements, and those are huge because they're always gonna be defined in the word problem. So what does C represent? If I go back to the word problem, I know that C represents the total cost to go to the game. So I'm gonna write that here. Let C equal the total cost, okay? And then T is right here. And T represents the number of people who buy a ticket. Number of people who buy a ticket. Okay, so if you think about it like this, now we're going to start writing our equation. I know that they drove together because it said that in the first sentence. They all are driving together, Hunter and his friends. Doesn't matter the number of friends who drove. We know that every car that goes into this game that parks is going to pay a parking fee of $7. And then each person, obviously, that enters the football game is going to pay $4.50. So that's $7. Think of it as like a literally one-time fee. Every person is not paying $7. It's a one-time fee. So I'm always going to start with the variable that represents the key word here is total. So I know the total cost of the game C. So I'm going to start with that variable. And it's kind of hard to pick out what variable to start with. That's one piece of advice we can give you is look for where it says like the total cost or total distance or total miles. That's how I'm going to start my equation. So I know the total cost to go to this game is going to be, well, $4.50. And each person has to pay that. So each ticket costs $4.50. So $4.50 T. And we define T by the number of people who buy a ticket. So I know I'm going to multiply $4.50 times T. Now, if you remember, and I had a bunch of my students maybe even just forget this, this represents multiplication. $4.50 T. I'm not using an X to multiply. I saw a lot of that last week. You can put a dot. A dot is fine, but really try to steer away from the X. We know that an X in algebra is a variable, not a multiplication symbol. So when you have a number next to a variable, together that means to multiply. So we actually don't need a symbol in between those two. So I know that now what am I going to do with the $7? I'm going to add it on to the end because it's a one-time additional parking fee. Okay, so I have C equals $7.50 times the number of tickets. I could be buying 7 tickets. I could be buying 8 tickets. It depends on how many people of Hunter and his friends are going. And then they're going to pay that $7 parking fee. So that represents a 2-step equation. Okay, I've got my equal sign, I've got my variables defined, and I've written it out. We're going to move on to problem 2. You can always use this video to reference back, especially when you do the Microsoft Forms activity. All right, problem number 2. Read it first. Joe took an Uber ride home from the airport. The Uber fee was $2.10 per mile. I'm going to highlight that. That's going to be important. And Joe tipped an additional $6 tip. Write an equation that represents the total cost of the trip home from the airport T. So T is the cost of the total trip, based on the number of miles it took to get home M. So there are our variables. They're already defined for us. Again, you'll never have to come up with what they represent. The word problem will always give it to you. So I know T represents the total cost of the trip home, and I'm just going to write out total cost. And then M, what does M represent? M represents the number of miles it takes to go from the airport to Joe's house. Okay. I know that when you tip somebody, that's basically a one-time thing. You're just going to add on, and there's the keyword additional. You're going to add on an additional $6 tip. Well, it could be, we don't know how many miles it takes Joe to go from the airport to his house. It could be a 5-mile drive. It could be a 10-mile drive. So what would we do per mile? What are we going to do for each mile that it gets driven to get home? Well, I know if Joe lives 8 miles from the airport, we're going to do $2.10 times 8, because each mile to get from the airport to Joe's house is going to cost him $2.10. So I'm going to start with the variable T. There's my keyword, total cost. I'm always going to start with that. T equals, so his total cost is equal to the $2.10. Okay? That's how much each mile costs. Well, we're going to times that by the number of miles, and I'm just going to put an M next to that. That right there, I hope you're all thinking right now, means to multiply, okay? And then when you have that additional $6 tip, we're going to add on $6. So I have T equals $2.10 times the number of miles it takes Joe to get home from the airport, plus the $6 tip that he's going to give his Uber driver. All right, we're on to problem number 3. A carnival charges a one-time fee. That's really, really important to understand that, just like all of the problems previously. On a one-time fee of $5 to enter, plus, okay, I know plus means to add, an additional $2 for each ride. Ooh. So every ride you go on at the carnival is going to cost you an extra $2. You might want to go on 5 rides. You might want to go on 10 rides. You might go on 20 rides. Well, however many rides you go on, you have to pay an additional $2 for each ride. That's really, really important. Okay. Carly paid a total of $23. So they're telling us how much she's already paid. Write an equation that represents the number of rides R Carly rode at the carnival. So right now I only have one variable to define. It only gave us one variable in the problem because it gave us a total of $23. That's the total amount of money she spent that day at the carnival. So I know R represents the number of rides she went on. And we're going to see this sometimes. This problem does not have two variables to define. It only has one because it gave us a total amount of money she spent. Okay, so I'm going to start there. I know she spent a total of $23. So $23 equals, well, let's go back. I know R represents rides, and she's going to pay $2 for each ride. So what I'm trying to think, what operation is going to show that I'm going to take $2 per ride? So if you ride, I'll make a little table over here. If you ride 3 rides, well, I know it's $2 for each ride. So 3 times 2 is 6. What if I ride 10 rides? 10, how much am I going to pay? Well, 10 times 2 is 20. So I know I'm taking the number of rides and I'm multiplying it by the $2 per ride. So I'm going to write this as 2R because that right there really means 2 times R. And then what's this one-time fee? So I'm going to add on a one-time fee of $5 to get into the carnival. So I'm just going to add it on to the end, plus 5. Now, we would also accept 23 equals 5 plus 2R. Okay. The commutative property of addition says order doesn't matter. We would also accept 2R plus 5 equals 23 if you wanted to put the equal sign at the end. So I can show that. We would accept this. 2R plus 5 equals 23. Okay, we would also accept it the other way. 5 plus 2R equals 23. So there's multiple ways to write this equation, but the components have to be correct. So again, when we write an equation, you need an equal sign. We also have to make sure that the variable is clearly defined, whether there's one variable or 2 variables, okay? In the previous problems, there was 2 variables. In this problem, there was only one because it gave us the total amount of money. So you will see both of these types of problems on your assessment on Friday. That's why we decided to put both of them in here. Okay, last problem. Here we go. Problem number 4. Your little sister is saving her money in her piggy bank. She already has $12 in her piggy bank. So no matter how much money she's saving, $12 is already in there. So that is her $12 in addition. Think of it to whatever she saves. Then she adds her $5 allowance that she gets each week. So that's important right there. I know adds obviously means plus. Okay, so we are going to write an equation that represents the total amount of money M. There's one variable. So that M represents the total amount of money she has based on the number of weeks W she adds in her allowance. So I've got my 2 variables. I've got let M. M equals the total amount of money. Total amount of money. And I literally got that, guys, right from the word problem. Okay? And then W represents the number of weeks that she's putting that $5 in there. So W represents number of weeks. Okay, last step, we have to write our equation. I know I'm going to start with the total amount of money she has. So M equals her total amount of money that she has. She makes $5 each week. So if I make a little table over here, I know in 1 week she has $5. In 2 weeks she has 10. How did I get that? Well, I know if I want to go from weeks to money, 1 times 5 is 5, 2 times 5 is 10. Okay, so I know I'm taking the $5 she gets as her allowance and I'm multiplying it by the number of weeks that she's going to put that in her piggy bank. And now, what am I going to do with this $12? Well, that was already saved in her piggy bank. So if I think to myself, am I going to add it, multiply it, divide it, subtract it, because those are the 4 operations, I know the only one that makes sense is to just take account for it. So you're just going to add it on to the end. I know that she had that $12 to start with. Now, same thing, just like the problem we just did above, if you wanted to write this as M equals 12 plus 5W, you can. But the W can't be attached to the 12. It has to be attached to the 5 because it told us that in the word problem. She adds her $5 allowance each week. We don't know how many weeks she's going to save for. That's why it's represented with W. Okay? So now after watching this video, I hope you feel a little bit better about writing a two-step equation. If you don't, watch this video again. There's no right number of times you can watch this. And then what you guys are going to be doing next is 5 practice problems on a Microsoft Forms link that will be in Schoology for you. Okay? All right, let us know and reach out if you have